Okay, so in the previous lesson we looked at how to solve a system of equations using graphing. And remember when we did that, the idea or our goal was to figure out where our lines intersected at, if they intersected at all. Because when we solve a system we're looking for a common solution. So by graphing, that common solution is going to be where they intersect. But remember we also talked about the fact that with graphing, the problem with that is that it's our least preferred method, just because a lot of times we're going to end up having to estimate our solutions. So if our answer is supposed to be a decimal, chances are we're not going to be real accurate. And you have to have graph paper to be accurate, and we don't always have graph paper in front of us when we're trying to solve these problems. So graphing is, like I said, is our least preferred method. So we have another method called using substitution. And this method is preferred when we have a variable like this first example here that's solved by itself. So we have y equals something. And you'll see why in a minute. But basically, so like I said, so there's going to be a total of 3 different methods. Each of these methods have their advantages and disadvantages. So like in this method, we're going to talk about substitution. In the next video, we're going to talk about how to use elimination. So when we have an equation, a system of equations set up like this, like I said, one of the variables are solved for by itself. We're going to take, because anytime I say y equals something, another way to look at it is y is the same as negative 4x plus 11. So if y is the same as negative 4x plus 11, I can put that piece in for y, or substitute it in for y in the other equation. So I would write this as 3x plus 6. But it's not 6y anymore, or 6 times y. It's 6 times the quantity of what y is, negative 4x plus 11 equals negative 18. So now what I'm going to do is I'm going to distribute the 6. Now notice the 6, it's a positive 6. So I'm going to distribute that 6 to everything in parentheses there. So it would be 3x minus 24x plus 66 equals negative 18. Now when I combine like terms here, 3x minus 24x, well that's negative 21x. And now I want to get the x by itself, because our goal is to figure out what x equals here. So what I'm going to do is I'm going to subtract 66 from both sides. And when I do that, I get negative 21x equals negative 84. So if I divide both sides by 21, negative 21, I get my answer for x, which is that x equals 4. Now it looks like a lot of work, which it was, but basically it was just algebra. It was just substituting this piece in for y, and then from there just doing algebra to solve for x. But the good news is we've also done the hardest part. Because now I just have to figure out what what x equals. I know that I need to figure out what y equals. I know that x equals 4, so now I'm going to do substitution again, except for I'm going to substitute this value of 4 in one of my equations. It doesn't matter which one, but obviously the first one would be the best one to use. So now I just take, to find y, I take negative 4, replace x with what x is, which is 4, and then add 11. And negative 4 times 4 is negative 16. Negative 16 plus 11 is negative 5. So it tells me y is equal to negative 5. You should always be able to check your answers to make sure that you have this right. So if I put 4 and negative 5 in my other equation, I should get negative 18 as my answer. 3 times 4 is 12. 6 times negative 5 is negative 30. And 12 plus negative 30 would give me negative 18. Let's try this with another one. And by the way, with these examples we're going to look at, the publisher has solved all of these for y. That doesn't mean that it always has to be solved for y. Sometimes you'll have x equals, sometimes you won't even be dealing with x and y's, and you might have variables like r and s, or m and n, in which case obviously you would have one of those set equal to 0. I'm sorry, set by itself. Okay, so let's take this one. We know that y is the same as negative 8x plus 1. So I can take what y is the same as and plug it into the other equation. So it's going to be negative 7x plus 4 times negative 8x plus 1 equals 4. So I've taken the second equation, the negative 7x plus 4y equals 4, and replace the y with negative 8x plus 1. And notice when I do that, I always put it inside of parentheses. That's really important because the next step is to distribute what's outside there to everything inside the parentheses. And notice it's a positive 4, so multiply everything by a positive 4. So negative 7x, then it would be 4 times negative 8 is negative 32, so it would be negative 32x. 4 times 1 is 4, equals 4. And here, negative 7x minus 32x is negative 39x. Subtract 4 from both sides, and I get negative 39x equals 0. If I divide both sides by negative 39, that means x equals 0, which is always nice when that happens, when we get x equals 0, because it makes it real easy now to find out what y is. So to find y, it's going to be y equals negative 8 times 0 plus 1. Well, obviously, negative 8 times 0 is 0, so that means y equals 1. If we check this answer, if I put 0 and 1, I can put it in the other equation. Negative 7 times 0 is 0. 4 times 1 is 4. And sure enough, 0 plus 4 gives me 4. So those will be my answers. Now, if you remember from graphing, we had some special situations. We had some times when we graphed, and the two lines were parallel to each other, which meant that there's no solution because they didn't intersect. We also had some situations where when we graphed it, when we graphed one line, the other line would lay on top of it, so they were the same line, which meant that there was infinite number of solutions. Well, that's easy to tell with graphing, but there's got to be a way to tell that with doing substitution. So let's look at these two examples. These are going to be two unique situations. This one here, again, I'm going to substitute negative 2x minus 7 in here for y. So now I'm going to distribute. Now make sure, like I said, like I was doing above, notice I was circling these numbers. The purpose of that is for you to draw attention to whether it's a positive or negative number. So this is a negative 3. So I'm going to multiply everything in there by negative 3. So negative 3 times negative 2x would make that a positive 6x. Negative 3 times negative 7 makes it a positive 21. So now when you notice, when I add these together, negative 6x plus 6x is 0. And I'm left with 21 equals 5. Well, that's not right. 21 doesn't equal 5. So here's a unique situation. If we ever get a time where the variables cancel each other out, so the variables are all gone, there's no more x, and I'm left with a false statement, that means I'd be left with no solution. So if I were to graph this, it would be a situation that would be parallel. So they're not going to intersect, so there's no solution here. Again, the way that we tell that is if the variables cancel out and we're left with a false statement, it's no solution. Let's look at the next one. So now I know y is the same as negative 3x plus 19. So if I replace y with negative 3x plus 19, I'd get this 9x plus 3 times negative 3x plus 19 equals 57. Again, I'm going to distribute. This time it's a positive 3. So it's going to be 9x stays the same. 3 times negative 3x, though, that's minus 9x. 3 times 19, that's 57. And if you notice with this one, the variables cancel out again, because 9x minus 9x is 0. But this time I'm left with a true statement. So that means that there is infinite solutions. Okay, so again, the key here is anytime the variables cancel each other out, that's going to be one of these two situations. So, by the way, with this one, again, with infinite solutions, if you were to graph it out, these two lines would share the same line. So again, that means that they intersected an infinite amount of points. But again, so if the variables cancel each other out, and you're left with a false statement, it's no solution. And if you're left with a true statement after they cancel out, you're left with infinite solutions. So I want you guys to pause the video, and I want you guys to work on this example. And this is going to be one of those unique situations that we just talked about, so I want you guys to see which one it is. So pause the video, work it out, and then hit play when you're ready to check your answer. Okay, So let's see how he did here. So we put this negative 2x, I'm sorry, this 2x plus 2 in here for y. So it's going to be negative 4x plus 2 times 2x plus 2 equals 1. Distribute the 2 through. So I get negative 4x plus 4 equals 1. These cancel out. You're left with a false statement. So there's no solution here. Okay. So hopefully you have an idea of how to use substitution now to solve a system. And good luck on that assignment.